Okay, today we are going to do this Newton-Raphson approximation method. Approximate, that means, okay, we start from a simple one. Let's say I give you this equation, x squared minus 4, then how you solve, you get this. That means you have two real roots. Okay, if you want to use graphical method to solve, you write this equation as a function, fx equal to x squared minus 4, and then this is a parabola with one turning point, x squared, one turning point, and then the two roots are on the x-axis. Okay, that's how you show two roots. So let's say I give you this one, x cubed, that is how we solve using the normal way. Then you get x equal to 3. By right, this one actually you must have 3 roots, but the other two are complex number. This one, how to get these two complex number, actually we learned already in semester 1 under the topic complex number. Okay, so we have only one real root. So in this topic we are only interested on real roots. Complex root we are not interested. So when you look at the graph is something like this. Okay, the equation we write as a function, and then the root is here. And then how about here, same thing, you see like this. Okay, you want to solve this one, x squared equal to 5, then is square root 5 and negative square root 5, so write as function the two root. So but if this case you see that there is undefined or x is not real, so there is no, the x-axis, the graph doesn't cut the x-axis, that's why no real root. Okay, so this is how we solve. Okay, now you look at x cubed. Okay, this one we can factorize. So let's say I factorize like this. I purposely do we can factorize. So we factorize, then you see we can have 3 real root. Okay, so 3 real root. If you look at the graph, that means the curve x cubed, we have 2 turning point, and then cut maximum 2 turning point. It can be 1 turning point or whatever. And then this one you see we have 3 real root. That means they cut the x-axis at 3 points. So the 3 real root. Okay, and then you look at this one. You look at this one, x cubed equal to this, and again this one can factorize, but here you cannot factorize. So what we do, you use the quadratic formula to solve. You have complex root. So you see the complex root, they always come in conjugate. Always they come in conjugate. They cannot come alone. They will always in one pair. Okay, so 3 root, 2 conjugate, and then 1 real. 2 complex root and then 1 real. So we are interested in real root. The real root is here. We write it as a function. The real root is here. Okay, so like just now, so you see this one is a complex root. You see, always conjugate. Okay, and then now we look at this one. Let's say I give you this. If I give you this equation, how many roots are there? This one you cannot see, isn't it? So what? So if let's say I will write this one as y equal to this, then you have to sketch this curve and y equal to 0. This is one way, but how to sketch this curve so that the root is here? What problem? So what we do like this. You look at this side. Okay, you write like this. This equation we write it like this, and then you like it to be a function. Function means you must have a y, so that we can sketch these two, y equal to ex and y. This is a straight line, so your ex is like this. This is a straight line. So you see these two function, the graph, they intersect at one point. That means the root, there is only one root, and then this root is positive because 0 is here. Okay, so from here you say the curve y equal to ex and y equal to negative, they intersect at one point. Therefore the equation given, this one equal to this or like this, has only one real root. We are talking about real root. Complex, I don't know. We are not interested. Okay, so now you look at the next one. Okay, let's say this one. This one you cannot factorize. So how many real roots are there? I want to know how many real roots. So you can let this one to be y. So you want to sketch the graph. But the problem is when you write like this, you want to sketch this graph. How are you going to sketch this graph? Very difficult. Of course you can if you really, but spend a lot of time. And then this curve, this is the x-axis. So the root is here. But how to sketch this one? Cannot. So what we do, not to say cannot, very tedious. Then what you do is you write this one like this. So you have one quadratic and one linear straight line. So you draw you write into two functions like that. Then this is a curve like this. You remember you learn in chapter 1 lower 6, and then this is a straight line graph. and then this graph is something like this, and then this straight line they cut at one point. So you see they cut at one point, that means they have only one real root, only one x, and this real root is more than one, isn't it? Greater than one. So the graph, this one and this one intersect at one point, therefore the equation has only one real root. Okay, so now you look at this one. Next, you look at this one. Let's say I give you this trigonometry and this one x from 0 to 2 pi. So if I let this one to be this graph, you cannot sketch. So cannot find the number of root. So if I write like this, let's say from here I write into like this. This is a linear, this is quadratic, trigonometric. So I can sketch this graph. If I put this one to be y, then I get y equal to this, y equal to this. This is a straight line. I put x equal to 0, I put y equal to 0, and then this is a part of trigonometric graph, trigonometric, like that, amplitude, and then this is a straight line, positive gradient, so like this, the y-intercept, negative pi, so the line is like this, so again they intersect at one point, so therefore the equation has only one. So the curve y equal to this one intersect at one point, therefore the equation has only one real root. And then the root x, this x, is greater than pi over 2 but smaller than pi. Okay, of course later we are going to find what is this using what we call Newton-Raphson method. Okay, now the last one you see, let's say I give you this. This also, if I sketch like this, cannot do because this graph you cannot sketch this graph. So you write it like this. This is logarithmic, this is linear. So linear, logarithmic, I substitute. So you substitute, you go and substitute this one, you know how to substitute, then you get the graph is like this, logarithmics, and that's they see they intersect at what point. So the two graphs, they intersect at one point, they have only one real root, and then the root is greater than 1 but smaller than 2, that means 1 point something, isn't it? So 1 point how many? This is what we are going to use the Newton-Raphson, but we cannot get the exact answer, we can get only the approximate. There is no exact answer. Okay, it's just like just now the first one, square root 5. Square root 5 also we cannot get the exact answer like that. That is 2 point something, isn't it? You cannot get exact value, square root 5. So this one is approximately. So like this you can do question number 1. Okay, question number 1 you see, to find the number of root. Okay, to find the number of root of an equation fx equal to 0, it can be defined by sketching two suitable curves. Just now I show you already how to get the two, and find the number of root of the number of point of intersection between the two curves. And then by sketching two suitable curves, okay, just like I show you already, of course you try to make one linear straight line, and then find the number of real root. That means find the number of point of intersection. Okay, so you can do this.